system on the end of an arm, and that arm can rotate down and push those digging buckets down into the dirt. This is the Utah robot. It has 3D printed buckets on a bucket ladder system. And Minnesota, just like that, has made it to the digging area. No problem. Those wheels on the Minnesota robot, those are 3D printed wheels, and then they coated them with rubber. And that seems to be a good decision. They didn't have any trouble making it through the obstacle field. Now we need to see the spinning bucket drum digger on the front of that robot start to spin up. And you see the light-colored conveyor belt just to the left of the bucket drum system. As that bucket drum spins, it dumps the dirt or the regular simulant onto that conveyor belt. There you can see it moving. That's Utah. We really like to see all 4 wheels moving. Utah has a lot of 3D printed parts. You can see the motor covers underneath that robot are actually 3D printed too. And you can see a red and white mesh on the Utah robot, inside the Utah robot, that actually holds the collected. Wow, that Minnesota robot is really digging deep. These robots need to dig deep in order to score, and this Minnesota robot definitely is doing that. On the left, the Utah robot, I was saying the mesh that is there to collect the simulated regolith, that's actually partly 3D printed too. That team really took a lot of effort into 3D printing a lot of parts. That Minnesota, I'm not sure it can get any deeper than that. That is a really deep dig right there for Minnesota. That is a powerful robot. The trade-off for that, though, is it might be a heavy robot. And so that can actually be a little bit of a point disadvantage if your robot is super heavy. But if the fact that your robot digs so much more than the competitors, if that offsets the minor point disadvantage that you get by being a heavier robot, then that's a design decision that is a smart design decision. All of these teams have a lot of different decisions to make. They have to make decisions on the weight of their robot. They have to make decisions about the data that they're going to use in the control room. Whether they're going to be autonomy or not, use autonomy or not. They have even more fundamental decisions like, do we use wheels or tracks for our locomotion? Which is going to do better? Which is going to perform better in this interesting material, which is made out of crushed volcanic rock? 5.5 minutes remain in this 10-minute run. The first of hopefully 2 runs for both of these teams. Now Minnesota is going to do some more digging, it looks like. They're going to go ahead and use as much time, maximize their digging time, instead of going back and forth and wasting time in the middle. The Utah robot on the left, they actually have 3D printed wheels also, but the Utah robot's wheels are actually 3D printed rubber. Instead of like a hard plastic, they actually 3D printed their wheels using a rubber material. Now we're seeing a good close-up there of the Minnesota robot digging. The students in the control room don't have this view, and so they're not able to see as well as we can see. I haven't seen their conveyor belt move in a while, and it appears that as those rotating buckets fill up, they're not able to spill out onto the conveyor belt because it's gotten backed up, which is why you see the buckets emptying out onto the ground. So there may be a problem with the conveyor belt system. We did see it move earlier, so it did work for a while. Let's see if they can get the problem solved in the next few minutes. Just under 4 minutes remain in this run for both of these teams. Utah on the left and Minnesota Twin Cities on the right. You can see the Utah students having a conversation about what their situation is. The Minnesota students actively working their robots. And looks like the Minnesota robot is backing up to the hopper. Let's see if they can get that conveyor belt to run and dump the material that's currently sitting on it into the hopper. You can see on this view, you can see cameras enclosed in plexiglass boxes. There's all of the electronics on this Minnesota robot are sealed very well, it looks like. Okay, they've got a mechanism that's raising. That's actually the dump, the onboard dump bucket, the onboard hopper that should have been filled up with the simulated regolith material, but it seemed like the conveyor belt wasn't working, which should have been transferring all that material into that onboard basket. So even though the team probably knew that that basket was empty, they went ahead and went through the motions because none of these teams have had a practice session. We have basically canceled all practices in order to maximize our chances of being able to run all of the teams through 2 cycles, given that there's a good chance that we will have some thunderstorm delays later on in the week. Minute 20 remaining. And it doesn't look like Minnesota Twin Cities was able to deposit anything onto the hopper, but they do have some experience and knowledge that they didn't have before, and so hopefully they'll be able to take this robot back into the pits, make some minor corrections, and come back strong for their second attempt later on in the week.